I am from Section 13 in CMP 295A, and our project is Substance Abuse Analytics and Prediction. So, like, our project advisor is Dr. Sanket Tavaragiri. We're a team of 4 members. I am Apurv. So, like, first of all, why substance abuse? So, substance abuse is like drug addiction today has got huge economic and social impact. Plus, the number of drug-related deaths is increasing every day. Then people are also falling for subscription opioids, and they end up being addicted to drugs. Then there's actually a lack of actual numbers to support the ground reality, and like there's no steps taken towards prevention of this. So in terms of economic impact, if you can see, like, these are the annual figures for each of the year. When you add these up, the overall impact annually for all of these drugs becomes like $740 billion, which is like more than the GDP of 170 countries. The number of deaths, as you can see, it has increased 6 times since like 2000. Then the prescription drugs, their use has increased like never before. So, like, if you've ever seen the movie Heroin, you'd know what I'm talking about. Then, like, as a goal of our system, what we actually want is that we want to build a preventive system that will predict the vulnerability of a person towards substance abuse. Then, like, we'll be performing some analytics, and we'll be taking background information from the user as input, and we'll be predicting the susceptibility of that particular user or a group of users towards substance abuse. And then, like, first step is to find any trustworthy data source, then perform some data analytics on top of it, and then use machine learning to build prediction models. And once the model is built, we're going to finally test it with varied input. So, like, the first challenge was that we were not able to get the data set properly because it's like a personal information, and it's very sensitive. So we had to go to like various sources, and like the data set we finalized consists of 1.7 million records, and it's from the University of Michigan, which is trustworthy. So I'll hand it over to Amit to explain project architecture. Amit.
Thank you, Apurv. Now we are moving to the architecture diagram of the project. So the entire architecture has been divided into 5 different modules. The first part is data source, which is on the rightmost part of the diagram. So the data source is like raw data, which we are taking from some universities. There we are also taking some business APIs data, and these data are used for training the model. And the third part of data is user input, which will be used on trained model to predict the substance abuse of an individual user. Now, the second part is transformation of data, where the data is normalized and being used for modeling the data. The third part is model training, where we use different machine learning algorithm to train the model so that the prediction happens with a good accuracy. Fourth part is deployment. Once the training has been done, we deploy on the server, which is directly connected to the desktop version. For now, we are only having the desktop version as a visualization. Maybe in future we'll be extended it to mobile version. So as a user, we have two users for now. One is individual user who can see his prediction. The other is agencies who can see multiple user prediction. Now, this is the low level architecture diagram, which is divided into 3 different phases. The first part is discovery phase. In discovery phase, we discover the data and test a different hypotheses and try to understand whether the data fits our requirement or not. The second part is cross validation phase. The cross validation phase is like we try to train the model with 80% of data, and then we test with 20% whether the data which has been trained is accurate or not. The third part comes as generalization phase, where the trained model is used for predicting an individual result. So this is the entire architecture diagram. Now I'll be handing over to Anshul to explain the different algorithm we have used.
Thank you, Amit. So now I will be explaining you the methodology that we have followed. So when we started off with the project, we decided to try out multiple algorithms so that we can decide on the algorithm that suits our need the best. So we have tried 4 different algorithms. First is two-class boosted decision tree, gradient boost classifier, logistic regression, and a random forest. Okay, so I'll explain you briefly the process that we have followed. So for now, what we have tried to do is try to predict the probability of a person, of a user, to be addict to a particular substance. So for example, the probability of a person to be alcohol addict, marijuana addict, or cocaine addict. So we have tried with multiple substances. So first we divided the data into training and testing data sets, like Amit has explained. Then we applied the filter clean, like the data filters, data cleansing rules onto the data. Then also we handled the biases over the data, for example, missing values. So we replaced the missing values with constant values. Also, we have tried different feature sets over the data so that we can optimize our results. So we have observed that when we tried out with fewer feature set, the results were not that great. But then we tried multiple combination and finalized few features that were giving us the optimal results. So this is a comparison chart between two of the algorithms that we have used. First is gradient boost classifier, and second is random forest. So as you can see, we have tried with marijuana, alcohol, cocaine, heroin, and other substances, and the results for these two algorithms were pretty similar. We have also done comparison of other algorithms. Now Harshad will explain you how we have created a demo using logistic regression. So I'll hand over to Harshit.
Thank you, Anshul. So we have created one application in which we will input some parameters regarding to the person, and the application will tell us that the probability of a person to be cocaine addiction, alcohol addiction, or marijuana addiction. So in the backend, we are using Python, and with the help of Scikit library, we are implementing logistic regression algorithm to give the output. So let's start the demo. So the first parameter is age. The age is 40. The race, education level, pregnancy, no, employment, no, arrested 2 times, the state, CA, the living arrangement, homeless. So let's check the output. So we are getting some graphs. So what these graph exactly shows is, for the first graph, we can see that it is 25% likely, or the probability of a person to be alcohol addict is 25%. Similarly, the probability of a person to be marijuana addict is 30%. And in the same way, the probability of a person to be cocaine addict is 56%. So this is all about our demo. For our next semester, we had planned to add some more features in our application and to increase the accuracy of our system. So thank you so much.